This is the Plaskets puzzle, considered to be one of the hardest puzzles in all of chess. Stockfish can't solve this. Leela can't solve this. Basically, no current-day chess engines can solve this puzzle. Many grandmasters tried but couldn't solve this, until Mikhail Tal, the magician from Riga, gave it a look and solved it effortlessly. But how did a grandmaster, rated 1,000 points lower than today's engines, manage to solve it? Well, the answer to that question is laziness. Before we get into that, let's take a look at this Mate in 2 puzzle. This is a well-known puzzle, and in a video, Magnus Carlsen himself solved it in about 2 minutes. Before we start solving this puzzle, let's just observe how our mind operates in any given position. Whenever you look at a position, your mind starts to calculate automatically. Most of the times you see the board and try to hold on to an idea which is relevant to the position, and you try to find moves revolving around that idea. Sometimes we find an idea first, and then the moves. Or sometimes the move itself gives us what the idea is. In the initial phase of calculation, our brain jumps to the most tempting moves, like checks or familiar patterns we've seen before. If you can't solve it that way, you start looking at the placement of pieces and what each piece is doing. But even then, the point where we start evaluating moves is arbitrary and abstract. If the best move is easy, pattern recognition and basic ideas are enough to solve it. When it's hard, you have to think deeply, and that's where the skill gap shows. For this puzzle, after looking at all the enemy pieces, you can deduce that only the rook or the queen can move. Moves like knight to c5 or knight to d6 would be checkmate if the queen and rook weren't defending those squares. And rook to e3 would also be mate if the king didn't have the d4 escape square. So, the move that solves this puzzle is queen to a8, because after that, either the rook or the queen has to move. And when we play knight to d6 or c5, it creates a discovered pin on the remaining piece. Although the queen can go to d4, which defends both of the squares, but this blocks the d4 square for the king, allowing us to play rook to e3 checkmate. Here you can see that to find the move queen to a8, you have to be aware of all of the following facts. The knight can checkmate on c5 or d6 if those squares are defended. The enemy queen and rook are the only defenders of those squares. Either the queen or the rook has to move on their turn, and our queen can set up a discovered pin for the remaining piece on that diagonal. The move rook to e3 is also a checkmate if the square d4 is blocked. It's very hard for beginner or for even intermediate players to find all of these facts because they may lack the calculation depth that stronger players have. We don't have a system or map to follow in a chess game. It all comes down to fragments of information, and the one who sees and manages them better is the better player. Whenever we search for a move, our play is already limited by the lens through which we try to see the position. That lens includes our past games, the games we have watched others play, the rules we have learned, the tactics and ideas we rely on most, and the mind's current level of adaptation to chess. You can watch Magnus Carlsen's game for weeks or months, but that doesn't make you play like him. Improvement mostly comes from the mind's adaptation. That adaptation is strongest when you play games on your own, and it's even stronger in childhood, when neuroplasticity is at its peak. But why does chess feel so difficult and calculation-heavy? Why is the game so vast and complex? It's because chess is a game of geometry. Calculation involves lines, diagonals, piece activity, and other geometric nuances with its multi-layered depth. Tunnel vision is what makes it tough. If we miss even one geometric relationship, we could lose the game completely. So how do we deal with the complexity? How can we make sure our play includes everything it should? And how can we avoid making mistakes forever? To solve this complexity, we need to solve the bridge between observation and solution. We need to see the entire bank we're standing on, the observation, and the bank we want to reach, the solution, and then we build the bridge of calculation in between. But this has to be done very carefully. Let's take a look at this puzzle and actually go through it. In any chess position, we have two phases and a byproduct. The first phase is observation. The second is calculation. And from these two phases comes our solution. We can think of it like this: observation multiplied by calculation equals the solution. To see how our observation leads to the solution, we first need to understand how our observation leads to calculation. So let's try to figure that out in this chess puzzle. We'll write down everything step by step until it's solved, so we can pinpoint the transition from observation to calculation. Here you can see the solution to the puzzle. We capture the pawn and give a discovered check to win the enemy queen. I'm showing you the answer directly, because how we arrive at it doesn't matter here. What matters is laying everything out clearly. So let's start in order. The number one thing we need to observe to solve this is to know that this is our turn to move. To bridge the gap between observation and calculation, we need to focus only on the moves, ideas, and facts that matters and plays some role in this. Fact number 2. Our bishop, our queen, and the enemy queen are all on the same rank. There are no pieces between our bishop and the enemy queen along that rank. The enemy queen is currently undefended. Our bishop is also aiming at the enemy bishop on e6. Our queen stands on the same file as that e6 bishop, and is just next to it on that file. Our bishop has a line of sight to the enemy king, but there are 2 pieces in between, the bishop on e6 and the pawn on f7. We have a rook on f4, which is currently eyeing the pawn on f7. Our queen controls g7 and h8, which are both legal squares for the black king. A queen move to g7 or h8 would be a sacrifice, since it would just get captured. But if g7 or h8 were defended, then a queen move to either square would be a checkmate. The move rook to f7 does 2 things at once. It removes the pawn on f7, and it defends the square g7. After rook to f7, 2 pieces still block our bishop's line to the king. One is the bishop on e6, and the other is our rook that just moved to f7. To avoid queen to g7 checkmate, the opponent is forced to capture our rook on f7 with either the king or the bishop. If the enemy bishop captures on f7, then only 1 piece remains between our bishop and the enemy king. We can then capture the enemy bishop with our bishop, which gives a check. That check cannot be blocked. The king must move or capture the bishop. It becomes the enemy's turn, and the king answers the check, either by recapturing or moving. It is now our turn again. We can now capture the undefended enemy queen with our queen, which is a game-winning material advantage. So we can see that from observation to the end of the puzzle, we have a total of 19 facts in our analysis. Up to point number 9 is observation. After that comes the calculation part. The key question is, what took place in the transition between fact number 9 and fact number 10 or 11? If we could identify that clearly, the process would be much easier. Number 9 says that our queen controls the squares g7 and h8. Point 10 and 11 says that either of the squares would be checkmate if defended. Between those 2 facts, we tested the idea of placing the queen as if it were defended to see if that would lead to a mate. This implies that we need to run a mate test for every move that a piece can control near the king. However, we all know that just doing a mate test is not the universal answer. It happened to work for this puzzle, but if the position were different, for example this one, or the starting position of chess, it would make no sense to do a mate test there. This conclusion relies on an abstract leap rather than a clear, universal process. It does not fit neatly into a logical system that can be applied to every position in chess. If this is not the answer we are looking for, then let's ask why we had to do a mate test there in the first place. We had to do the mate test because it was the biggest threat available. Even though it would not have worked out, we used that threat to win the queen. Let's shift our focus back to the board for now. We'll revisit that later. Let's look at the move rook to f7. That move does 2 things. It defends the mate square, and it takes the pawn on f7. If the enemy queen was only 1 square down, we could not play rook to f7, because the discovered check tactic wouldn't work. This means that to even consider rook to f7, we must see the whole sequence beforehand. But this is another example of the calculation loop, because there is no way to find rook to f7 without seeing the discovered check tactic. What we are trying to do here is overcome the calculation idea loop. In this case, we found the solution first and then worked through it. But if we could instead gather all the facts and observations and map them out in a clear, linear order before starting any calculation, the problem would be solved. The problem is that we have to jump into the future by calculating deeply, then return to the present position and keep repeating that process, using trial and error to find the move. To solve this, we need something, some form of light, to guide us through our calculation. That light could be finding the best path in the current position, which would then lead us toward other possible paths until we reach the solution. In our case, that light is experience and pattern recognition. The normal way of playing chess, even for grandmasters, has its limitations because it relies heavily on intuition rather than a clear structure. I mentioned at the start of the video that Tal solved Plaskett's puzzle using what I called laziness. What I meant is that the human brain is lazy, and when its intuition is at its finest, it skips over all unnecessary data and goes straight to what it feels could be the answer. But this intuition can be flawed, because it is also shaped by factors like emotions, our surroundings, and countless other small things which we can't keep a track of. Grandmasters often depend on experience, pattern recognition, and deep positional understanding. While this is effective, it is still subjective and can lead to errors under pressure or in completely unseen positions. So coming back, what is the light that will guide us? What is the one thing that can finally break this dilemma? Whenever we are unsure, we search for something to guide us. In those moments, everything else fades, and one thing matters above all. That one thing, the light that will guide us, is the goal itself. The game of chess has one ultimate goal: to capture or checkmate the king. But in actual games, that is rarely the immediate goal. In most positions, the current goal might be something different, such as capturing a piece, developing a piece, or trapping an enemy piece. By goal, I mean objectives. So, to solve all of this, what if we wrote down every objective that exists in chess? If we lay out all the possible objectives, we no longer have to rediscover the point of a position from scratch every time. In the position I showed you, the objective was to capture the enemy queen. If we had already known that this was our goal, the chances of finding the right move would have been much higher. We ran a mate test and used the threat of mate to achieve the objective of winning the queen. In this case, the condition for completing the objective was creating a checkmate threat. I mentioned earlier that the mate test would not work in every position, and that's true. But every position still has its own objective, and the conditions to achieve it may be different. If I told you the objective in any chess position, you would almost always be able to find the best move. Which is why the missing element, the light that will guide us, is the objective for the current move. There are several ways to find the current objective in any chess position. One example is simply observing the position and letting our intuition guide us, which is the normal way of playing chess. But what we are trying to do is avoid that and instead create something systematic and as close to errorless as possible. What we can do is list out every objective a chess move can have and work from the biggest objective down to the smaller ones. If we were to create a map or a chart, the highest tier objective would be observed first, followed by the second highest, and so on. Our system works by moving through possible objectives one by one until it matches the real goal in the position. In this puzzle, capturing the queen was the objective, and that falls under the category of capturing a piece. The system would test objectives like mate, and if that didn't solve the position, it would simply move on to the next category. By working through objectives step by step, the process ensures we eventually arrive at the correct goal without depending on guesswork. We could then observe the position and identify the conditions and setups on the board that would help achieve each objective. Some moves could serve multiple objectives, and by threatening to reach a higher objective, we can restrict the opponent's options and still secure a lower objective. This idea is still nuanced and needs refining, but it's our best shot because it turns raw calculation into structured system. What I mean is this. Imagine we write the objectives out in a graph, with the conditions being the current board realities, the tactics, and the plays available. From there, we could start at the highest objective, like checkmate, and check if the conditions exist, for example, a skewer. If they do, we use it to deliver mate. If not, we move to the next feasible objective, maybe trapping a piece, and check the conditions for that as well. Chess might be infinitely complex, but the pieces are the same and limited, which means the objectives themselves are few and calculable. I will share this whole graph in my next video and show how it can be applied in real chess puzzles.